All right, here's page 4 of your practice. These 3 problems all dealing with logarithms, our new topic this week. So let's dive into this first problem right here. Remember, logs were created here to solve for some exponents, which we have right here. But we want this to be an exponent form first. Okay, we want a very simple number to an exponent is equal to another number. We want it that simple. We need to get rid of the extra stuff, if you will. For example, this plus 6. This plus 6 needs to be moved to the other side first. So we're going to end up with 1.1 to the x power is equal to 15 when we subtract 6 from both sides. So this is the form we need. A number raised to an exponent is equal to another number. At this point, what law number 3 of logs tells us that we can apply the word log to both sides of this equation. Keep it balanced, keep it equal. What we do to one side, we did the other. Law number 3 tells us that we can take an exponent from this location and move it to the front of the log, basically turning it into multiplication and still keep the log true. So that exponent moves to the front. And in some of these problems, it'll move back to the exponent. So you need to be able to know that it goes both ways. The nice thing about moving that out front here now, you can divide by this log of 1.1 to eliminate it. But what you do to one side, you would do to the other. So x is now by itself, and this is what it's equal to. So I'll point out now, we have a problem on our final exam that doesn't allow a calculator. And when it doesn't allow a calculator, this is what you would be looking for. This is what would you type on your calculator in order to solve this problem? And you would be looking for this. Okay, so that's just kind of a heads up of what's coming. But I'm going to give you your calculator, and if you have your calculator, you need to punch that on your calculator. So let's see what we get. We're going to round that to the nearest hundredths. So put this on the screen so you can see it. I'm going to hit the log button, which is a nice convenient button next to my 7 here, and that's 15 goes next. You have to remember to close that parenthesis. That officially ends the log with just the 15. Divided by, now we introduce a new log of 1.1, and I'll go ahead and close that too. So I'm punching that on my calculator. It's closing that parenthesis there. That's very important. And I see 28.41. And that's the answer that you would need to have here since it says round to the nearest hundredths. Okay. If I slide over here to B, you'll notice this one is starting in logarithm form. And I would suggest this, if you're ever looking at something that's in log form or you're looking at something that's in exponent form and you're stuck, rewrite it in the other form. That's why we practice going forward and backwards in the writing, just to see if it triggers something. If you're looking at this and you're going, I'm stuck, I don't know what to do, rewrite it in exponent form just to see if something clicks. For example, 5 is the base. It would be written first. The 3 is the exponent. It would go next. And then this guy here would be last, written out here by itself. And if you're looking at this going, oh, I can solve for x. Look at that. That's just an algebraic equation. So logs is how this problem started, but it's not a log problem. It didn't need to be. If you rewrite this in exponent form, this is very friendly. 5 to the third power, first of all, is 125. So I'm going to swap that out first. Add 4 to both sides, 129, and then divide by 2. And looks like you're going to get 64.5. We stayed away from our calculator. Okay. C goes back to problem A. Your unknown is up here in the exponent, so we'll definitely need logs, but I need to get rid of the extra terms. I only want the number that has the x by itself. So we got to get rid of this 17, and we got to get rid of this 4. So I subtract 17 from both sides. That's going to get me a 3. Then I divide both sides by 4. Please don't multiply those two together. That would be very, very bad. So 3 divided by 4 is just 3/4. Now, if you want to use 0.75, since the decimal is exact, you can use 0.75. So I'm going to go through the log laws again here. So the log of this side is equal to the log of this side. Law number 3 tells me to move that log x out in front of this log. Watch, I'm going to do 0.75 right now. See if that you like that better. And then you divide both sides by log 3 to get the x by itself. Cancels, and this is what I'm going to go punch in my calculator. Log 0.75, close it, divided by log 3. Negative 0.26. X equals negative 0.26. Let me show you something on the calculator in case I never do this in class. This calculator has kind of a cool feature if you wanted to check your work, but not all of you have this calculator, so I wasn't big on showing it. But I'll show you now in case you're watching this video. This STO button down here by the on button stands for store. So if I hit that button right now, it says, I'm going to grab this previous answer and I'm going to store it. And I could say, hey, will you store that for X? And X is its own button right here. It has this other stuff, but X is the default. So I'm telling my calculator, take this number in its entirety and store it for X. And I hit enter. And you might be thinking, well, why would you do that? Well, a cool thing about that is on this calculator, I can go retype this equation here and see if it gives me 20 as the answer. Then I know this is right. Watch, I could type in 4, left parenthesis 3, to the x power, and see what the calculator is going to do is put that number in there for x, which is cool. And then I've got this plus 17. So all I've done is typed this side, telling the calculator to put my answer in there just to see if it gives me 20 as the answer, which it does. So then I know I got it right. So that's why this calculator has some cool features. That's one of them I like. Just being able to check your answer is kind of nice. You just can't use a rounded answer. If I were to type in 4 and then times 3 and I just type in negative 0.26 plus the 17, I'm going to be slightly off because it didn't put the exact answer up there. See how it's slightly off? So that might freak you out. And that's why I used the previous answer button, or I stored it. When I store it, then it uses the exact decimal that goes forever, which is kind of cool. Okay. These problems are raising to the reciprocal. Okay, so if you take a look at this guy, we want to raise to the reciprocal to get rid of an exponent. However, on this problem, we want to get rid of that 6 first. So let's divide both sides by 6, which would turn 360 into just 60. And that 6 is gone. Raising to the reciprocal is done because it creates an exponent that's raised to an exponent. The rule is to multiply these together, but a number times its reciprocal is just 1. So that just turns into an ugly 1, which is just x to the first power. We don't need to write that 1. So that's why we do it. But what you do to one side, you do to the other. So now I've got to head to my calculator and type 60 to the 3 over 2 power, which was the reciprocal we did on the other side. 60 to the 3 divided by 2 power. 464.76. 464.76. Round to the nearest hundredths. Okay. E. X plus 1. Again, this is a logarithm problem. If you're stuck, if you're looking at it, and I kind of jumped the gun here. If you're looking at it, you're like, I don't know what to do here. Rewrite this in exponent form. So that's what I'm doing right now. I'm rewriting this just so I can take a look at it. This is the base. This is the thing that has the exponent. So I need parentheses. That's kind of crucial because that represents the entire base. The 4 would be the exponent, and the 80 would come out here solo. So I rewrote this log form in exponent form just to see if it could help me solve this problem. Now, I can get rid of this 4 by raising both sides to the reciprocal. So if I raise both sides to the reciprocal of 4, that 4 would be gone. I would need to punch 80 to the 1/4 power on my calculator. 80 to the 1/4 power. That gives me an answer of 2.99, which I'll go ahead and write right here. But then I would need to subtract 1, right, to solve for x. So -1, didn't need to do that. 1.99 is my answer. 1.99. Okay, F. F, we need to know that guy right there, which we practiced a long time ago, if I were to rewrite this, get rid of the radical symbol, is just x to the 3/5 power, right? That's just x to the 3/5. We should know that one by now. Now, just like D, okay, very similar in the steps that D had. I'm going to divide both sides by 7. And when I divide 105 by 7, 105 divided by 7, I conveniently get 15. And then I need to raise 15 to the reciprocal of 3/5, which is 5/3. 15 to the 5/3 power. 91.23. Okay, I'm going to stop that video since that took longer than expected, and I'll do another video for the last half of page 4.